theorem. That is Riemann's removable singularities theorem. Let U be an open subset of a Riemann surface X, and let A belongs to U. Suppose F belongs to O U minus A. That is holomorphic on U minus A. F is holomorphic on U minus A. And if U minus A to C, I should write this. If U minus A C is holomorphic. Is okay. Suppose F is bounded. In some neighborhood of A, then F can be extended uniquely to a function F tilde which belongs to OU. Okay. So recall this type of singularity is called removable singularity. A function F has isolated singularity at Z equals to A. This function is from C to C. I should write this. What is this? if that is C to C as singularity at x equals to a, if there exists r greater than 0 such that f is analytic a but not in whole, is isolated, and uh, if you can extend uh, to BAR total, then it is called removable. The point A is called
Do we need that open set to be connected in the definition above?
what?
In the statement of the theorem above, do we need you to be connected?
In this theory,
Hmm? Hmm. Hmm.
Shrink it if necessary. You may choose connected.
So I'm just asking whether it is necessary or not. I mean,
uh, it is bounded in some neighborhood. So you may take connected.
okay. Uh, yeah, bounded in some neighborhood of A. So, হ্যাঁ হ্যাঁ ঠিক আছে, অসুবিধা নেই।
এটা স্ক্রল করলে উপরে যায় না নিচে যায়, আমি এটা ঠিক বুঝতে পারি না, কোন সময় নড়েও না। Okay, A is called a removable singularity if there is an analytic function G B A R to C such that GZ goes to FZ for all Z belongs to. Okay, so now theorem is if in complex analysis in C, theorem is the function if F has isolated singularity at A, then the point A is a removable singularity if and only if limit A 0. Okay, so I'll discuss some a proof. Proof is very interesting. All of you know that. Just recall this proof. Suppose F is analytic in BAR minus A. Okay. Define G C GZ equals to Z minus A FZ if Z not equals to A equals to 0 if Z equals to A. Since limit suppose suppose limit Z minus A FZ is 0, it is given. This implies G is continuous at a claim G is analytic on BAR. Then F has removable singularity. Then F has removable singularity, right?
Yes.
Because G is the extension. Not G, sorry. You can write then GA is 0. So G can be written as Z minus S into some 8Z. Then 8Z is the extension. Okay. By power series expansion. Okay. Now we will proceed by Morera's theorem. Okay. We apply বানানটা ঠিকঠাক লিখলাম Morera's
হুম
theorem.
হুম 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 হুম
অভিরূপ এমন হ্যাঁ করতে শুরু করেছে মোরেরাকে রোজ দেখতো তো একেবারে।
তখন বলছিল না যে শেষাদ্রির সঙ্গে বসবে,
হ্যাঁ
সাথে চা খায় তো।
let us consider triangle.
এটা রেকর্ড হচ্ছে বলে আমি বলতে পারছি না, তা নাহলে আমি তো নিজের নিশ্চয়ই আর থাক।
Consider a triangle.
সুরতনদার গাইড এসে পিটবে তোমাকে।
Suppose this is BAR. বহুদিন ছবি টবি আঁকি না, এই দেখো ছবি আঁকছি, কেউ আমাকে ইয়ে করবে না, সবাই মন দিয়ে দেখবে। Suppose triangle is this type of triangle. There is no triangle delta, right? Triangle delta in BAR. If A does not belongs to delta, then delta is homotopic to 0. BAR minus A, right? If I choose this domain and A does not belongs to delta, BAR minus A, then it is homotopic to 0.
Yes.
Okay. So this implies, note that G is note that G is analytic on BAR minus A. Okay. So by Cauchy's theorem, Cauchy's theorem, what is this? Integration delta of G equals to 0. Okay. So in this case, we are done. Suppose case 2. Suppose A belongs to delta and A is a vertex of delta. This type. Oh, okay. What happened? This type A. So I write this is a point O P Q. This is not in, this is inside in the disk, not on the boundary. Okay. So pick in the picture O is the point A. Okay. Pick 2 points RS. R belongs to PQ, belongs to the straight line. R a point R a point on POP, and this is your R point, this is S. S a point on OQ. Okay, on OQ. Then integration delta G. This can be written as integration of this triangle I write it as triangle ORS. ORS, what is this? ORS, I write this is triangle delta, where I will write what is this. Then polygon the RPQS polygon G, okay, where delta is the triangle ORS and P is the polygon or quadrilateral RPQS. Okay, so I can write this. Now, now P, sorry, O does not belongs to A, either. A does not belongs to the polygon P. So this implies P homotopic to 0 in B, A, comma R minus A. This implies integration P G equals to 0. So RS is arbitrary. So we can small take limiting, in the limiting sense, we can take this RS near as O. This is RS. We can take this. So
Then we can apply the approximation, I think. I mean, that epsilon thing.
actually that is integration G is integration delta G. Okay.
So once we take mod, that is less than equals to supremum of G over the delta times delta. I mean, then delta goes to 0. So the whole thing, the perimeter of delta will go to 0. The whole thing will go to 0.
See, G is continuous.
G is bounded on delta.
And GA is 0 for any epsilon greater than 0. We can choose RS such way
So
that
the perimeter of that delta is, I mean,
such way that
the perimeter of delta is less than epsilon.
bounded. This is bounded.
Hmm.
G of Z is less than epsilon by length of this triangle. This is perimeter. The length of delta. Okay. This implies as R tends to 0, so what happened? Integration delta G is lesser equals to mod GZ into length of delta, right? ML inequalities less than epsilon. Since epsilon greater than 0 is chosen arbitrarily, then we have integration delta G, sorry, it is 0. This implies integration delta G is 0. So in this subcase, next we assume A on just only, this is special case, A belongs to just delta. So this is your A This is your delta. So we can, and A is not a vertex. So we can divide it by 3 triangle. Now A. So we can divide integration delta. This is your T1 triangle, this is your T2 triangle, this is your T3 triangle. So integration G is your integration T1G plus integration T2G plus integration T3G, and both all are 0 by the previous case. Now can you see that this is interior? If it lies on interior, so what happened in this case? If it lies on uh, edge, middle, some edge of this triangle, can you say এই কেসটা কি হবে?
Isn't it a corollary of the second case?
ওটা জানতে চাইছি।
So we can actually compute the whole triangle actually. I mean, that
But
arrows will have to.
মিড
You
পয়েন্ট
just
থেকে অপর দিকে কোন কর্নারে
add this
হ্যাঁ ওটাই কি বলবো
A. This is your T1, this is your
Hmm.
T2.
And we'll have to choose the orientation accordingly.
This case, and this case is integration delta is your it choose convenience orientation this way and take same way. Okay, integration T1 G plus integration T2 G equals to 0 by the previous case. Okay, so this is your Riemann. No, this is not. Okay, so far we have proved that G is analytic. Now G is analytic on BAR, triangle BAR. So far we have proved this. So now what is GA? GA is 0. That is definition. So thus we have proved G is analytic on BAR. So it has power series expansion around A. That means G Z equals to A0 plus so GA is 0 given. This imply this imply A0 is 0. This implies GZ is Z minus A into some HZ, where HZ is analytic on BAR. So Hz is, note that what is definition of gz. If z not equals to a, z minus a into a, fz. So fz must be, by identity theorem, fz must be hz for all z belongs to b, a, r minus a. So hz is the uh, required extension map. And I write and. This is the proof. Okay. Now apply it. Now this is Riemann removable singularity theorem for your Riemann surface. Now apply it. Take a chart, then apply it. F compose that chart. Apply this theorem. Okay.
Hmm.
Theorem. That is identity theorem. Suppose x and y are Riemann surfaces and f1, f2, x2, y are two holomorphic mapping and f1z, f2z for all z belongs to a subset of x, and that is with a derived non-empty. Then f1 equals to f on x. Okay. So you have proved this version in complex analysis. What is the version? If you suppose f has a power series expansion a0 plus a1 z minus a n z minus a whole to the power n plus dot dot dot. If infinitely many ai's are zeros, then f is identically zero, right? Hello.
Hmm.
If infinitely many ai's, I want to say that if there is a infinitely many, that is wrong statement. I want to say that if for some point a it is a0 plus a, sorry, a0 equals to a n is all at 0 for a point a n 0, then f is identical to 0. So I can
Well,
say
the
that
problem
what
is that Hamanda,
what
I think
AI, AI
if you have written,
if I
I think
what
if you have written, yeah, that form is better, I believe. Can I otherwise, I mean, we think that AIs may not depend on that A.
oh
Hmm.
okay. So
Hmm.
I am not writing this. I write this way. That's it. That suppose recall that I write this statement. Recall in the complex analysis case.
Because otherwise, the proof is pretty straightforward. I mean, once we have the result, we can just use a chart, and I mean, that's how the proof is done. I mean, everywhere in this theory.
Mathematics lies in complex analysis.
Yeah.
Okay. If G is connected, note that domain is connected, Riemann surface. See, be analytic with G is open connected set domain. Open connected set, then following are equivalent. Number one, f is identical to 0. Number two, fn a is 0 for all n belongs to natural number for some a belongs to G.
Hmm. Hmm.
This is because we can write f as power series and fn is coefficient.
Hmm.
ZF has a limit point
Limit.
in G. Okay, limit point in G. So this is main. So using it is take it as homework.
The
Okay,
uniqueness theorem.
that is the uniqueness. Okay, next, and this is homework. Do it with charts. Use this is also homework. This is also homework. Next, we introduce a definition. Let X be a Riemann surface and use subset of X open set. If uh, write this way. By a meromorphic function, on y, we mean a holomorphic function on y, not y, on u, I write, because u, we mean a holomorphic function if u prime to c, where, note the domain, u prime subset of u open with number 1, u minus u prime contains only isolated point number 2, for each p belongs to u prime, this isolated point, limit extends to p mod fx is infinite. The point u minus u prime are called poles of f. And mu is the set of meromorphic functions on u. Okay. So what can you say about OU and MU? Note that if G belongs to MU, this implies F plus G belongs to MU, F dot G belongs to MU, and C2 MU theta, Z goes to I write A goes to FA, where FA is the constant function on U. So mu is the C is the ring homomorphism. Theta is the ring homomorphism. So mu is the C algebra. Okay. Can you say why f plus g belongs to mu? If g belongs to mu, then why f plus g belongs to mu?
A plus G is holomorphic outside the set of poles of F union set of poles of G.
Yes.
So, and union of these two sets are closed and discrete. So we
And
have
no. And what about this infinite?
that also holds na. And that if I take any point P from set of poles union set of poles of G, so either FP goes to 0 or FP goes to infinity or GP goes to infinity. So if I put limit, so one of them must go to infinity. So the sum goes to infinity.
And
Same for
similarly,
same for product also.
same for
Product.
product.
Is it true?
So
No, the product, I mean, one can go to 0, the other can go to infinity. I think that's the case.
No, I am taking the union of set of zeros of F and set of poles of F and set of poles of.
Yeah. So
Ah,
suppose
but I understand. But there might be element set in poles, but in zeros of G and poles of F. Yeah.
oh yeah,
So
then we can take out, I believe. I mean, so say, I mean, it will be like if there will be like z minus p whole to the power m into f1, and g will be z minus g1 by z minus p whole to the power something. So
no. I am not using any structure theorem of holomorphic function. Just use এখনো ওটা বলিনি।
oh,
hmm.
How can you say that?
Then we can do that. Take the set of poles of F union set of poles of G and remove the common zeros, if any. If there is some zeros of F and some zeros of G which lies in that set, remove them.
Suppose P is a point where F is 0, FP 0, and G
gp is
has
infinite.
We discussed
uh,
that. No,
this.
Yeah.
In
we
can you say that it is
Okay, I think we can say one thing. Then if yeah,
FG has
either a pole or a zero, at least that is that is something we can say.
what do you mean by either pole or 0?
No, so I am saying is that, so suppose p is a pole of p is a pole of g and a zero of f. Okay, so if p is 0 and gp is, I mean, gp goes to infinity. So what I'm trying to say is that, so if g of p, I mean, that is, I mean, limit fz gz z tends to p is either 0 or infinity. That is my claim.
Why? You says that limit x tends to P if G of x
see
Hmm. Hmm.
is 0 or infinity, right?
no, the issue is if X is a pole of F, then X is not defined at the point X. So I mean there is no point of multiplication there. The multiplication is defined wherever both of them are defined.
Yeah.
So
Yes. No, that is fine. But the thing is that we will still have to show that that limit goes to infinity in that case.
yes, in that case, limit goes to infinity. We need to show, right? So, so I mean, we cannot say okay if GGX like that. So
Mm.
What about limit? I'm not saying that FG of P.
uh,
That's why I wrote limit. But still, we can break the limit actually. Like f times something, g times something. We can't. Uh, I mean,
no,
what
but if we
it
try it,
by the Wolfic functions. Okay, I think we can do one thing there. Mm,
no, what if we realize the monomorphic functions on whatever u or the domain on the set of all holomorphic functions onto C hat, and then we multiply them there using.
This is even higher technique.
No, that's not hat technique. I mean, that's the correspondence, na? Set of all. I mean, any meromorphic function on domain, same as holomorphic function onto C hat.
Then
Then we'll multiply. We can multiply at least using infinity times infinity equal to infinity. So that makes sense.
then
Then this problem does not occur. That if, I mean, f of g.
yes, but you will still have to show that the limit exists. Might be infinity, but you will still have to show the limit exists, right?
No, if suppose x is a pole of f and 0 of g.
P, the pole of F
Yes.
and 0 of G, yeah.
Then fp equal to suppose 0 and gp equal to infinity.
Hmm.
I mean, then we can make sense of product. That is 0. But somehow we have to make sense of product. I mean,
Again, I mean, that same problem. I mean, how will you define Fp times Gp, 0 or infinity? That's where the order of the pole comes into play, or order of the 0 comes into play. But we can't use the structure theorem here. I mean, structure theorems of like holomorphic functions or taking out zeros, factorizations, all that.
The answer is, if limit fg x tends to p, it is not infinity, then by removable singularity, Riemann removable singularity, we can remove this. We can take and take a function which is which has no pole at p. Okay.
No, but one thing, I mean, if the limit is not infinity, I mean, how do we show that it is bounded? I mean, it may happen that the limit, I mean, for some subsequence, the limit is infinity. It may happen that the limit does not exist actually. I mean, it has a divergent subsequence to infinity, but it has other things as well. I mean, that says that limit extends to p if x exists and is infinity. The limit
Existence. What is problem? Existence.
Now, how do we assure that limit fx gx extends to p, the limit exists? I mean, it may be infinity, but how will you assure that the limit exists? Because once we are saying that the limit is not infinity, that doesn't mean that the function is bounded on that domain. I mean, to use that Riemann's universal singularity theorem, we need the function to be bounded.
Yes.
But it may happen that the limit is not infinity, but it is not yet bounded. A one subsequence is, suppose one
No,
sequence goes to
no,
one
no,
and
no. P belongs to what? P belongs to what?
the set of poles of G, say.
P belongs to your uh, what? So limit x tends to p fx exist. It may 0 or may infinity. Limit x tends to p gx, that is also exist. It may 0 or it may infinity. If limit x tends to p fx g, now fx, what can you say by fx is gx?
Okay, so basically I understand. I mean, what I was saying is that if, say, if there are two different sequences, xn and yn, going to do different limits, so then fxn, if gxn and fyn, gyn will go to different limits. So it means probably that fxn, gxn, they can't, I mean, exist individually, I believe.
That is the catch.
This is the logic I think Riemann was using then. That, I mean, once we have infinity, we can do this thing.
এটা ডিলিট করে কি করে?
এটা
Press
দাও, কাটার
delete.
অপশন আসবে তো।
হ্যাঁ,
Press delete.
ওই মানে কিবোর্ড থেকে মারতে বলছে। কঠিন কাজ।
ওকে। Theorem. Suppose X is a Riemann surface and F belongs to meromorphic function. So F is defined on some open subset of X, and X minus U is isolated, and these also exist. Okay. Limit x tends to P of Fx is infinite for all P belongs to X minus U. Define, suppose F is defined on U to C, where X minus U is the, just 1 minute, give me 1 minute. Suppose X minus U is thus is the set of poles of F. Define F tilde X2 no, sorry, Riemann sphere. What is this? Z goes to Fz if Z belongs to U, and equals to infinity if goes to infinity if Z belongs to X minus U, that is in pole. Then F tilde is a holomorphic map. Because you know that C union infinity Riemann sphere is also a Riemann surface, so this makes sense what is holomorphic map. Okay. Sorry. Conversely, if F x2 C union infinity is a holomorphic map, then either f inverse infinity goes to x, or I should write this way, f inverse infinity is an isolated set subset of x and in this case f x minus f inverse infinity to c is holomorphic. uh, is holomorphic, or I write is a meromorphic function. Okay, I should write this way better. Belongs to mx. That belongs to mx, meromorphic function on x. Okay. Can you check that it is isolated subset? Can you check it? Now, at first, if it is not, see that if f inverse infinity equals to x, done. Okay.
If it
If
is
x, f inverse infinity is not x, then it must be isolated subset. If it has a limit point, because if it has a limit point, then f inverse infinity should be x, because it's identically equals to infinity. Okay, by identity theorem. So f inverse infinity either equals to x, or it is an isolated subset of x if f is holomorphic map. Converse part. Now,
yes.
the state part. What is this? Can you check this is a holomorphic map?
Just take a chart here and take a chart.
So you have
X is
to,
holomorphic outside the set of poles. We need to show that X is holomorphic at each point of the poles. So take a chart there and take the chart 1 by z at infinity. And if we bring it down there, we will say that it becomes 1 by fz type of things.
okay, your idea is absolutely right, but I need writing. Okay. So this is your input homework, this part. And this part is easy. Use identity theorem. This for this part. This is homework. Check it. This is holomorphic. Okay. Next. Recall the definition. and a set is a topological space is called simply connected if it is connected and every closed curve is homotopic to 0. I should write topological set if it is connected and any closed curve gamma in gamma homotopic to null homotopic is null homotopic. Okay, I write a homotopic to 0 means null homotopic. It is contractible. Okay. In X. What do you mean by 0? That is null homotopic. That is every closed curve can be shrink into a point. Constant curve. Constant map. Okay. Recall famous theorem of Cauchy. If analytic function on a simply connected domain, if you uh, uh, compute integration, line integral, then it is 0. If G subset of X is a simply domain, then integration gamma f equals to 0 for every closed rectifiable curve and every analytic function f on G. That is your Cauchy's theorem. Now, what can I say? Observation. If G subset of that is not X, I want to write that is subset of C. If G is subset of C, are simply connected domain, if and f is analytic or holomorphic, whatever you want. If G to C is analytic G, then f has a primitive. Proof. we fix a point A belongs to G. So if gamma 1, gamma 2 are two paths from A to Z, Z is any point, let Z belongs to your just 1 minute G. If gamma 1 and gamma 2 are any two path same direction, then you see that gamma 1 minus gamma 2, that means gamma 1 in direction gamma minus gamma 2, let gamma 1 gamma 2 be to any path in G from A to Z. That means gamma 1 0 to gamma 2 0 equals to A, gamma 1 1 to Z. Let minus gamma 2 is T equals to gamma 2 1 minus T. Then gamma 1 minus gamma 2 is a closed path in G at A. Okay. So by Cauchy's theorem, what is this? By I don't know what is this. By Cauchy's theorem, we have integration should be 0. This simply integration of gamma 1 f equals to 12. So if I define if we define fz equals to integration gamma f, where gamma is any path from A to Z in G, then f is well defined, capital F is well defined, is because it is path independent. Now what about f dash z? Can you see? We claim capital F is a primitive of F, smaller. So this is the catch when this integration is path independent. Fix Z0 belongs to G.
Are we taking the triangular path? I mean, from Z0 through Z0 plus H, then
Any path will be through, no?
Any path. Suppose this is your G, there is A to Z. Now Z0. So take straight line just. So Z0 belongs to G, and choose R greater than 0 such that B A R Z0 R subset of G, because G is open set, we can choose R. Let gamma Z is gamma plus the state line Z0 to Z. This is A to Z0, this is Z0 to Z. Okay. So what is your FZ? FZ minus FZ0 by Z minus Z0. What is FZ? FZ is your integration of gamma F, right? Because A to Z. Then what is FZ0? FZ0 is A to Z0. That means you should write minus integration. I should write Z to Z0 better. A to Z, Z to Z0. Integration gamma Z, gamma plus Z to Z0 by Z. So it is your integration gamma F. You know that it is integration gamma F minus integration Z to Z0 F. This will cancel, and that is integration Z0 to Z F by Z minus Z0. Now, what can you say?
Yes,
What
now
can you
limit Z10 to Z0.
what is this?
The line will shrink to a point. Integral is 0.
Now, what
So
is Z2 to Z?
Z2 to Z is straight line, na?
T1 minus TZ. What is
Huh.
this?
Line segment joining
One
Z0 and T.
Z0 plus TZ, right?
So going Z0 to Z is same as going T tends to 0.
Yes, omega is 1 minus T Z0 plus TZ. So d omega is, what is this? Minus Z0 plus Z. Okay, that is Z dt.
dt.
dt लिखले भूलूंगा. Z minus Z0 dt. And what is this? F 0 to 1, sorry,
Yes.
integration Z0 Z F is 0 to 1 F 1 minus T Z0 plus TZ
Z0 minus Z minus Z.
Z0, sorry, Z minus Z0 cancel out. Z minus Z0 by Z minus Z0 dt, right?
Yes.
So 1 by this is equals to this. So limit z tends to z0, integration z0 to z f, just 1 minute, by z minus z0 equals to limit z tends to z0 into 0 to 1 f 1 minus t z0 plus tz dt. It is uniformly continuous, so I can apply z f1 minus t z0 plus t z0. I can apply limit dt. So tz0 cancel out, f z0 0 to 1 dt, that is f z0. This implies f dash z0 is f z0. So we are done. So what is observation? If G is a simply connected domain and F is analytic, then F has a primitive. Okay. Using this, next day we will discuss branch of logarithm exist in simply connected domain. And you can take some nth root of analytic function, which is also analytic. Okay, any question?
No, not as of now. এটা দেখিনি তারপর কিছু হলে জিজ্ঞেস করবো মানে।
Please, সোজাই।
These মানে এগুলো তো just elementary এখন খুব একটা অসুবিধা। Ritik and Hassan has joined. Hassan, you are from Kashmir, right?
Yes.
And Ritik is our student, I mean, from our academy. এই আর একজনেরও তো থাকার কথা, one more was supposed to be there, I think. His name is Nikhil Rai, I believe. Where is that guy? Whatever.